Welcome to my channel. Today we are going to talk about the stochiometric mechanism. So let's think about a reaction that occurs through a series of distinct steps, and each step can be written as a chemical equation. So this series of steps are what we call stochiometric mechanism. So we have dissociative mechanism. We can even call it D, or we can even write DA for dissociative just to simplify things. We also have the associative mechanism, and we also have the interchange mechanism. So in terms of the dissociative mechanism, consider this mechanism here. So if you check on this mechanism, we experience, let me have my pen ready so that I can also be writing. We experience first a slow removal of X. Can you see the X here? It was like this before, and then a slow removal of X. From there we have the 5 coordinate intermediate here, this one, because it's 1 2 3 4 5 attached to M here. So it's 5 coordination intermediate. From there we can see a fast addition of Y, and as a result we have reached the product. This is the product here, right? So this now corresponds to an SN1 mechanism. So let me write SN1 here. It corresponds with SN1 mechanism of nucleophilic substitution of, or in organic chemistry. And then the rate of reaction depend on the slow step. So this will be the rate of the reaction, will be given by K. Let me also have a square brackets here. Let me have my central metal and ligand. How many ligand? A 5 ligand, and what? And X. So this will be the rate, or the rate will depend on the slow step, right? So now we can also have the associative mechanism. So this time around, the associative mechanism differ from the dissociative one. This time around, addition of Y occur before the removal of X, as you can see. In other words, in associative mechanism, we have a 7 coordinate intermediate, because we have 1 2 3 4 5 6 7, right? And then after the addition of Y, after this addition of Y, that's where now the removal of X occurred, and then we have reached the product. In other words, the product can be the same, but the way in which, or the way in which the reaction occur can differ. So in other words, this time around, this associative mechanism followed the SN2 mechanism. It follows the SN2, or it corresponds with the SN2 mechanism of nucleophilic substitution in organic chemistry. So now the rate depend upon the first step, right? So this time around, the rate will be equals to K. We'll have a K here, square brackets, M and L for ligand, 5 here, X. From there, square brackets, let's also have another square brackets, and let's have Y, right? And close the brackets. So that will be the rate. So now if you check, it's simple and easier to distinguish between the associative and also the dissociative mechanism. So should there be evident that the structural or the spectroscopic of an intermediate has a reduced coordination number, like this one, you can see that there's evidence, right, of the reduce in coordination number, then we know that we are dealing with the dissociative mechanism. And should there be evidence, right, of the intermediate having an increase in coordination number, then we know that we are dealing with associative mechanism. But now, if there's no identifiable intermediate, then we can assume that there was an interchange mechanism, or an interchange mechanism is operating. So we can assume that, in other words, this is the example of the interchange mechanism. So we can think that this one is then operating, right? Whereby this is the transition state here. Let me also have my pen. Oh yeah, I can even show with a point. So that showing that this one is in the transition state. It's not clear whether Y was inserted before X was leaving or not. So thank you so much for watching the video. Don't forget to subscribe to my channel. Thank you.